A common process for solving complex problems is known as computational thinking. And as we learn, complex problems have no best solution. Computational thinking is the thought process between formulating a problem and expressing its solution. Computational thinking has 4 steps, and we're going to go over all 4 with an example. The first aspect, decomposition, which has to do with breaking a complex problem down into smaller, more manageable parts. For example, find the sum of all numbers between 1 and 200. How can we break this problem down to smaller equations? Well, 1 plus 2 equals 3, 3 plus 4 equals 7, 5 plus 6 equals 11, and 7 plus 8 equals 15. But if you notice, this is really time consuming and it's not tenable to do all of this. So we can't do this. We'll try something else. So let's try a different set of combinations. We have 200 plus 1 equals 201, 199 plus 2 equals 201, 198 plus 3 equals 201, and so on. We can kind of see that something's going on here. So the step 2 of computational thinking process is pattern recognition, the process of identifying patterns or trends within a problem. So let's return to the problem we started in step 1 and find the sum of all numbers between 1 and 200. What pattern do we see here? If we take the sum of the high number and the low number, we get 201. And all the other pairs have the same sum. We need to figure out how many times the 201 patterns repeat. Well, you could count all the pairs, which would take a long time, or just take the high number and divide it by 2. 200 divided by 2 equals 100 pairs. If the sum of each pair is 201, and we have 100 pairs, we can now determine the sum of all numbers between 1 and 200. Step 3 of the computational thinking process is abstraction. Abstraction suggests we identify specific similarities and differences among similar problems to work towards a solution in our original problem. And in order to do that, we had to find the sum of all numbers between 1 and 200. So let's look for similarities and differences in all of the pairs. Well, one thing we noticed that all the pairs have the same sum, so we can get rid of those and we can focus only on the important details. And if we do that, we can see and express the problem as an equation. 200 plus 1 tells us the sum of each pair. 200 divided by 2 tells us the number of pairs. Multiply them together, and we find that the sum of all numbers between 1 and 200 is 20,100. Fourth and final step of the computational thinking process is algorithm design. This involves developing step-by-step instructions for solving the problem. And you can use this again and again to solve similar problems. So in our original problem, we had to find the sum of all numbers between 1 and 200. So step 1 is to find the sum of 200 plus 1, and we get 201. Step 2 is to find the quotient of 200 divided by 2, and when we do that, we get 100. Step 3 is to multiply the 2 together. So when we get that, we get 201 times 100, which is 20,100. And now that we've solved it, this algorithm can actually be used to find the sum of all numbers between 1 and any number. So let's see how it works with 1,000. So step 1, 1,000 plus 1 is 1,001. Step 2, 1,000 divided by 2, and that's going to get us 500. And step 3, multiply the 2 together, and we end up getting 500,500. So as you can see, computational thinking is a step-by-step problem-solving process that lets you break down any complex problem to help you solve it. And we're going to be using this in computer science.